Okay, so the next problem in the lead code we are solving is word break. Okay, this is a solution, but actually, yeah, like I mean, in the internet, like I mean, it will be like little concise. I've just elaborated it to make it clear. Okay, in the internet you might have come across this solution already. Okay, so let's try to understand this problem. Okay, so this is a there is a given string. Okay, yes, and like I mean, there is a word dictionary also. So what is being asked here is we need to break down the string into multiple pieces of words. Okay, and those each word should be a valid. How do we say valid? Valid is nothing but if it is present in a dictionary, right? Word dictionary, it is a valid string. Okay. Okay, so basically this is a string. We can, if we can break it into Leet and code. Those two words are also actually present in a word dictionary, so it's a valid. Okay, we can say you can say that this true can be segmented into the Leet and code, so it's a true. So again here, right, we can segment it into apple, pen, apple. Both the words are present here, so this is also true. But here, right, what we can actually we can get multiple combinations here. Let's check that out. Okay, cats and dogs, right? I can pick cat, that is there. There is also word cats. We need to try both of these combinations now. Okay, so if I take the cats and the next word, if I look for, there's a and. Okay, there is a and, but there is no word called og, like I mean og is missing here, so it's not a false. So now let's check the cat. Okay, previously we think we took cats, now we'll take a cat combination. Okay, if I take this one, there's a word, also word called sand, right? Okay, but I will again end up with word this at this index, but we'll not find og, so it will be a false. So basically it cannot be segmented into proper words. Okay, this is a dictionary given, we couldn't segment this. Okay, so basically like I mean it's a problem of the combination, right? We need to try out this combination and everything. Now let's see like how we can solve this problem. Okay, let me open. So as we said that this is a problem about combination, right? So whenever it's a combination, like I think we can simply apply the brute force, right? We can try out all these combinations and check if it is existing or not. Or we can simply approach, as it's a problem of combination, we can use the backtracking also, right? Backtracking, again it's nothing but a recursion, right? Yeah, we can use that actually, like I mean we'll get a solution also. But the problem here is like the time complexity. Like if this word increases, like for each of the index, if you're trying to do the check if it exists or not, right? I will also, let's say that there is one more word called app, correct? So I will also have to check this one, and I'll be going forward, and let's say that if I don't find it, I will have to start again from the start, right? I will have to start checking for the Apple word, right? It's again like we are trying to, I mean, that will increase the time complexity, correct? So now, how to improve the time complexity of that, right? Basically, like one option is like instead of doing the same operation and again, right? Let's say that we are looking for a word Apple, and we found some character combination, and we did some calculation, but it failed somewhere. It failed, okay? And when we start from the beginning, we should be in a state to reuse it, okay? So how are we going to reuse it? We can reuse it only if we store it somewhere, correct? We'll cache it somewhere. Okay, memorization. So when we cached, to reduce the number of operation, if you are reusing the already performed calculation, right? This is nothing but a dynamic programming, right? We will improve this the backtracking algorithm with the help of the dynamic programming here by storing the already performed the calculation. Okay, now let's see that, understand. Okay, now we know that we'll have to improve it, and we'll use the dynamic programming, but we don't know like what to store, like what is the dependent, or like how they are interconnected or anything. To make it simple, always we'll have to start with the, like I mean, by writing the decision tree, right? So once we write a decision tree, we can try analyzing how these things are connected and what is the dependent, what is repetition happening. Yeah, this everything. Okay, so let's take the first example. Okay, let's take this as an example. So we are going to build a decision tree for it. Okay, how are we going to do it? So basically we'll be starting from here, and then we'll try out each of the combination. Okay, so what if this matches, what if this matches? Okay, if there is one more word, we'll have to try that also. For simplicity, we'll use this. Okay, so finally we'll start with here, and we'll have to start with the initial index, right? We'll have to start from here. Okay, and also we should not overflow, so we can check the length. 5 plus 3 8, 8 plus 3 is 11. So length is 5 3 8 8 plus length is 13. Okay, so we will be using the zero index, so it should not cross the 13. Like I mean when we are here, 13, like okay, if it is a perfect match, right, our index will be finally here, I believe. That's what the I can say. So okay, let's say 13 is here, 12 is here. Okay, let's see, let's come to that point later. Okay, so now what we'll do, we are here, so I need to pick each of the words that are present in the dictionary, and I will have to check if it is matching or not, because if there is a word called app, right, I need to consider this also. That's why we'll pick one word from here and then compare it with his one. Okay, what is the length of this one? 5. So I will match the first 5 character strings. Okay, first let me see what are the possibilities, right? I will have to make a decision tree. So this is option I have, and the next option is to check with the word pen, right? What I will do, if it is matching or not. Okay, currently we are I is equal to 0. Okay, okay, wait a minute, let me. Okay, first we calculated the length, right? So basically apple and pen, if we compare it, this one will match, right? This one will match, but this will not match, correct? We'll ignore this for now we'll ignore this. So now next thing is I will have to start checking from here, correct? I will have to start checking it from here, and and I should be, and also I will increase here, correct? I was initially here, I need to move to be here now. Pointer I is equal to some, this will be 5, correct? So initially I is equal to 0 for this one, and here what is the length of this? The length of the string that matched is 5. So I is equal to previous I plus 5, that will be I is equal to 0 plus 5. The new I will be here. Okay, I is updated now. Okay, so this is match, this didn't match, we ignore it. So next we'll again do the same thing. We'll have to check with apple, we'll have to check with apple, and we'll have to check with the pen, correct? So if you do the calculation for this one, apple will not match, right? I is equal to 5. If you check it, obviously it will not match. P character for initial character will not itself match. Pen will match. Okay, so now I will have to shift my I to the next level. So what is the length of this character string that is matching? I is 3, right? I is equal to I plus 3. So 5 was initial value, so it will be I is equal to 8. So we are moving our pointer. So finally if we just check the again, if we check it again, apple will be here, apple will be here, and pen will be here. These are like, if there is any another words, right, this will just keep on increasing. Okay, currently we have only 2 words, that's good for us to explain. Okay, so this will match, finally this will match. Finally what will happen? I is equal to 13, correct? I is equal to 80 plus 5 is 13. Okay, so what does it indicate? When I, if we are able to reach the I is equal to 13, right, it means that we are able to reach, we have reached the end of the string, correct? If we are able to properly break down this string into proper words, right, our I will be pointing to the end, correct? So now we can say that this is a valid, we found a string actually, like, I mean, this is a valid segmentation. We simply have to say true or false. Like now as we are able to reach the exact to the end of the string, so we have no characters left to analyze, and we have not overflowed it. So it's a valid string, we can say return, we can return true. Okay, so this is not matched, so we can just ignore. Okay, so what do we need to analyze here is, what we can analyze from here is, so basically like, I mean, if there is one more word called apple, app and le. Okay, app, there is a word called app, and there is one more word called le. Okay, app and le. So what will happen? I will go to the app first, and then I will go to le then. Okay, so what will be the I here? I will be again is equal to 5, correct? I is equal to again, like I might have reached this point by two way. I can either go use the word apple and go here, or I can go to app first and then le, right? Whatever the way we go, like, I mean, it doesn't matter. From here, if we are already sure that if we are able to reach the destination or not, if we are aware that, that's good for us, correct? I don't have to calculate again and again. So basically whatever the path it is we took, ultimately if we are at some point, if we know that if the path is connected and if we can go to the end, we are good here, correct? Okay, so why am I telling this is, let's say that we are there are three folks. Okay, there is a folk one, and person two, and person three. Okay, we want to go from here to here, right? And he can, what the first person can do is, he can go and go to the end and check by himself, or else what he can do is simply ask this guy, right, if it is connected or not. Okay, he will ask this guy. Okay, he is at the, if he is at the end of the string, right, yeah bro, this is connected, you are connected, he will say this connected, he will connect it. Okay, so let's say there is one more path, there is one more person. Okay, there was one more person in a wrong path or something it is. Okay, so if you ask him, like, he knows that, he will ask the other guy, and he knows that it is not connected, right? Ultimately, like, if you are able to, if you are in his place, you know that you are not, you are in a wrong place. I mean, to simplify, you are at some position, you can simply ask the child nodes to answer for you. Okay, so if it says it is false, you are not connected, we can simply return as a false. If he says it is connected, you can simply trust him and say that, okay, this path is going to the end, so it means that it's a valid string. Okay, like, this can be broken into multiple segmentation. Okay, this was just a example. So here what we can analyze here is, so basically here, right, in order to tell I is equal to 0 whether it will reach or not, I need to know if I is equal to 5 connected or not, correct? Let's say that if I is equal to 5 can take me to the end, right? If I know name it, I can directly conclude that the result as true, correct? See me here, similarly I is equal to 5 is dependent on the I is equal to 8, correct? And 8 is depending on the I is equal to 13, correct? And we know that I is equal to length of the string, right? If the I is pointing this, it means it's a true, correct? We know I is equal to, this is the case only thing we know. But I is equal to 0, when we start from 0 we don't know 5, we don't know 8, everything so here basically the lower value is depending on the higher index values, okay, to avoid the calculations and again. So we simply ask this guy 8, we simply ask finally we'll simply ask the 13, it's a valid, it's the length of the valid length string, so it will be considered as this one, okay. So what does it imply here is, so basically in order to calculate, first we need to know the end values, bigger index values, okay. So to write a dynamic programming, so now what does it indicate is, let's say that if you are maintaining some cache, right? So that different index for a different index we'll see like if there is a connected to the end or not, if we can generate a valid string or not, okay, we'll store the result. Like how are we storing? We are not starting from the beginning, because I is equal to 0 is dependent on 1 is dependent on 2, like that, right? Like I mean finally we need to know the end values to write to know the values of zeros than the initial values, right? So first what is one thing is, okay, let me clear this out. Okay, what did we understand here is basically like I mean the lowest values is depending on the highest. So like I mean we know that we'll be using a dynamic programming and we'll be caching things. So but to cache itself, right? Like I mean if we want an answer for overall, like I mean if I'm standing here, I need to know that if it is connected or not. I mean, if I'm able to break the string or not, so I can rely on it, right? So basically, what we are going to do here is I is equal to 0, right? So we are not going to come from here this time, as I is equal to lowest values are depending on the highest values. 0 was depending on 5, 5 was depending on 8. If you see the previous example, right? 8 is depending on 13, correct? So it means that we should be knowing 13 before actually calculating 0. So and also we know that 13 is true always, because that's a valid one, right? That's if the I is pointing to the end of the string, it means that we are on the right place, like it meaning that we have checked for all the characters that is present in the string, okay. Now we need to calculate for 12, 11 and all those things, okay. Now let's check that how we are going to do it. Okay, so as we discussed, if the these are the caches, okay. So I is equal to 0 is depending on 5. We need to calculate the 5, okay. And how do we calculate 5? This is depending on 8. We need to know 8 first, okay. And how do we know 8? 8 is dependent on 13, and but we know 13 is good, okay. 13 is good, but this for this problem 8 is dependent on 13, but it like I mean for other combination we might be depending on something else also. So we need all the values that are present in between here, okay. So let's say that, okay, now what we are going to do here is we'll have to calculate for next one, right? So what we'll do is I is equal to 12, we'll set our pointer here and then check, do the same thing, pick one word, do the comparison and update the value. So here, right here is, it's just one character, but there is no one character that is matching anywhere, so we can just simply say it is not matching 12. And we can also check 11, right? Length itself are not matching, so we can just say no. And also the 10 also, right? 10 meaning this is 12, this is 11, this is 10, right? This will also not match. 9 and 8, okay, till 9 there will be no match for length itself, so everything will become empty, okay. So now this will be interesting for 8, right? 8 is pointing to this one, okay. So now if you check the string, right, I will compare it first with a pen, it will not a match. So I will just compare it with the next one, apple, okay, this is a match, okay, there is a match. So I will add the length, okay, like what will be the next string, if I am at 8, 8 plus what is the length, 5 is equal to 13, whichever the index. So I have a connection from 8 to 13, that's what it means, right? 8 is connected with the 13. So what does 8 say, is it connected or not? Okay, it is true, so I can trust him and say that, okay, if I can go to 13, I can go to the end, that's what it means, okay. So now we are done. Similarly if you go it backward, right? So any, like if you try to compare it with any of this word, it will not match, correct? 8 will not match. Yeah, there is no string that it will take you to the end, that's what it means actually. If you can take 7, it will not a match. And if you check with comparative the, that will also not match with any of the word that is present. But if you check with the f5, it will be a match, because we are already analyzed it in a tree, we are just writing it this way, okay. So pen, right? Like I mean pen, so pen will match. So pen will take you to what is the length here? Basically here we are at 5, what is the length of this? It is equal to 3, it will take us to the 8. So I will talk I will ask the 8 if it is a valid or not. Okay, we already solved it, correct? We already solved it. Yeah, bro, it is true. So you can trust me that I have asked that 13. It also tells that, it also told that it's connected. Okay, so that's what it means. So I asked 8, and 8 actually dependent on 13. So it said true. So I can simply trust him. Okay. Similarly, this is what will happen for 0 also. Okay, everything in between will become cancel. So if there is any combination, like once we build this, right? So now we know that from 0, if I start, there is connection or not. Okay, if there is no connection, ultimately this will become false, right? Let's say that if this was dependent on 3, okay, I will ask 3, but 3 says that it's not connected, bro, I don't get any path. Like if you trust me, like I mean, if the high points to, if any combination leads to the I is equal to 3, this will not get to go to the end. That's what it is. Okay, finally, whatever the status that is in the beginning, we can return that as a result. Okay, now the video is getting lengthier. Let me just quickly go to the implementation. Okay, so basically, as far we discussed, right? So what we'll do is we'll have to first we'll initialize everything to the false. Okay, it means to that we have not reached to the end. Okay, and finally, like we'll set 13th location, whatever the 13th there was, right? That is true. Okay, because we know that that is the end of the string. That is the only thing that we know when we start the program, when we start the execution. So that will be true. So now we will be coming from the last index, and we'll check for each of the word in the dictionary. We'll compare it. If it is overflowing, will not continue because that's not a valid one at all, right? So whatever the string, right, we'll see if it is overflowing, and also we'll compare those words, like whatever the word we get here and whatever the index, we'll compare it first. If it is matching, then we'll ask the status for the next available. So whatever we are here, right, we'll ask the next matching string if it is the matching or not, just like this we did, right? Once we are at 8, we check that it's a valid, and then we'll check with this one. Once we are at 5, we'll check with 8, right? That's what we are currently doing here. So once we know that it's a matching, so we'll check the ask the next valid if it is connected or not. If it is not, we'll be just saving it as false, else it is true. Ultimately, like we could have tried multiple combinations here, right? So one is apple, we tried for apple, and also there can be chance for app also. So we'll have to keep a track of everything. Like I mean, whichever, if it gives a true, let's say that if this gives a true, okay, but for this a pen, this is false, correct? So we picked it from true or false. Like I mean, if one of them is true, that is fine for us. We picked this option, correct? So that's what. So we'll be trying out all the combination, and we are storing the status basically. If any of the path will result into the end, it will have this true status. If any is true, we'll be finally concluding it as true. So let's say that 8, right? From 8, it's not that, oh, this is the only path, right? We could have gone to the any other also. Let's say if there is one another word called app. Okay, here if I take for app, it will, I should be querying for this one, correct? I will ask the 11. I will ask the 11 if it is a true or false. It will say false. Okay, and also there is one more combination, that is apple. Okay, this will take me to query the 13. Instead of 11, I will query the 13, but this return true. So it means that there is at least one path that will go into the true, that will going to be true, that I will be considering and updating it to true. Okay, so if both everything is false, I should be considering this also as a false. Okay, so that's why we'll be storing this in a temp, and we'll be checking if any one of them is true or not. Okay, or else we can simply, we can, what we can do is we can directly check for the status here itself. Okay, if it is a true, we can consider it as a true. Like we just need to consider only one, right? We don't need to check for everything. We can simply put this status is equal to true here, and read the status of I, whatever this one is here. Okay, we don't need even temp, but I am adding it here just to make it clear that we are going to try out all the combinations, and we'll be giving it here just to understand it properly. Or else we can just use this here. So if at least any one of them is true, we can just set the status is equal to true and break out of that loop. Okay, that's it. Thanks. Okay, but let me just quickly revise it. The video has become too much lengthy, and also I don't edit the video. Like I would like to complete in one take, so I might have stumbled in between. But let's revise it quickly. Okay. So what did we do here is, so this is a problem. Is here like this, and it's a problem of combination. Okay, like I mean, we are combinating. Like I mean, we are trying out all the combinations here. Correct. So as it's a problem of combination, it's straightforward that, like I mean, we will have to go for a backtracking. Even though if you implement a backtracking, you will result in a time complexity error. So other option we have is a dynamic programming. Okay, so how do we implement a dynamic programming? We'll have to not repeat the too many multiple like, I mean, we should not repeat the same operations again and again. So how are we going to do it? Like by storing the cache. Okay, now we know that we are going to use it, we'll be using a DP, and we'll initialize the cache. Okay, so we'll have every time we write a dynamic programming, we'll write a decision tree to understand what is dependent on what. So based on that, we will be building our cache. So it can either be top down or bottom up. Like it's meaning like we might sometimes we'll have to build our cache from the beginning, I is equal to 0. Sometimes we'll have to build it from the end. Here we could clearly see that I is equal to 0 was depending on the higher number, so we started building our cache from the end, and we knew the initial value that I is equal to 13. In this case, the end of the string was valid, we set it to true, and we use that value to evaluate the any other I mean upcoming indexes. Okay, and yeah, that's it, I believe. Yeah, thanks.